Hey Girl Scouts, today we'll be using electrochemistry to engineer batteries.
We'll be creating a multicellular battery out of mostly household items.
This process will show us the principles of oxidation reduction reactions, how electrodes and electrolytes yield electrical properties.
This is similar to how Alessandro Volta made his first electrochemical battery in 1799. Volta used plates of zinc and copper separated by a cloth that was soaked in a saltwater solution.
During this process, the zinc oxidizes, causing it to lose electrons, which are gained by the ions in the water under the process called reduction. This process produces hydrogen gas, allowing for an oxidation reduction cycle.
For this experiment, we'll need ice cube trays.
Galvanized nails. Galvanized means that they have a zinc coating on the outside. Copper wire, which is going to act as our conductor to let the electricity flow.
Vinegar, which acts as our electrolyte.
An LED light to power.
Don't forget your safety glasses.
And a pair of pliers, or something that you can use to cut the wire and to work it safely. The first thing you want to do is take a length of copper wire and cut it. You're then going to take that same length of copper wire and wrap it around one of your nails. Make sure to wrap it tightly so that the nail doesn't slip out from around the wire coil.
For this experiment, we made 27 wrapped nails.
You're then going to take the nails that are wrapped in the copper wire and put one in each cell of your ice tray. Bend the wire, the extra length, in a U shape so that it touches and goes into the cell next to it. If you're using multiple ice trays like we are, you want to line them up and treat them as if they are one ice tray. So I will put this nail in this last cell and make sure the wire goes into the next one. Once you've done that on the whole first row, on this last cell, you're going to put the nail in, but have the wire go to the cell behind it instead, like this. You're then going to continue this process back the way you came. Once you've done that all the way back to the end, you're going to put in your last nail in the second to last cell. Remember, we had as many nails as we had cells, minus one. This last cell does not get a nail in it. You want to make sure that every nail and the wire coming off of it does not touch the nail or wire of any of its neighbors.
Now we're ready to add our vinegar, which is going to act as our electrolyte. Make sure that you fill up just enough to cover the copper wire. We don't want it to be overfilled, but as soon as it hits that copper wire, you are good to go. Now that everything's set up, we can actually see the reaction. There are tiny little bubbles forming. This is the vinegar dissociating into the solution, and it's providing our charged ions. If we follow the path of conductivity, we have from negative to positive or from zinc to copper. So the nail is acting as our negative, the copper is acting as our positive. So we can follow that all the way down. Negative, positive, negative, positive, negative, positive.
Now that our battery is constructed, we're going to hook it up to our LED light. This is what ours looks like, but yours may look different. The important thing to note is that it has a positive and a negative side. On this one, this little spring is the positive side, and around the outside, which will be this metal band on this little cup that we've cut out as a holder, that will be the negative side. So what you're going to do is I'm going to put it in our little holder and attach a wire to the positive side. Once you have that positive wire connected, you're going to put the other end of it into the cell, the last cell that has a nail in it. Once you're all set up, you're going to insert that wire into the last cell without a nail, and then you're going to touch the other side to the negative part of your LED. This reaction has very low amount of power, so it's going to be kind of dim, so we're going to cut the lights to help you see a little bit better.
Okay, now let's compare our homemade battery to a 9-volt. So here's our 9-volt battery, and I'm going to do the same thing. I'm going to hook our positive to our positive and our negative to our negative. Much brighter. But hey, we still made a battery.
Thanks for joining us for National STEM Day. I hope you've enjoyed this experiment and seeing how STEM can light up your day. Please join us for other activities. You can visit our website or our YouTube page and see other fun STEM experiments, or look for our mobile STEM center near you.